Let's review the centers of triangles. This is from topic 5. We have 4 different centers that we're going to review in this video: circumcenter, incenter, centroid, and orthocenter. And if you remember, as we started this section, we talked about concurrent lines. And concurrent lines are 3 or more lines that will intersect. So if you look at these triangles, we've got a line, we've got another line, and another. And notice they are all intersecting at one point. And that point is called the point of concurrency. Now we have special names for the points of concurrency based on the special features of the triangle. So let's start out by reviewing the circumcenter. The circumcenter is created by perpendicular bisectors. And if you recall, 2 lines are perpendicular if they form a right angle. So these lines are perpendicular. They are perpendicular to the sides of the triangle. And again, notice that little box? That's telling us that it's a 90-degree angle. So these lines are perpendicular. Now, bisecting, when you bisect something, you are kind of dividing it into 2 equal parts. So if you notice here, we have our congruency marks. These are the little tick marks. So that means AZ is congruent to ZC. AX is congruent to XB. And again, that is because this bisector has come and divided this segment into 2 equal parts. X, Y, and Z would be midpoints. Now, some important facts. The circumcenter is equidistant. So equidistant means equal distant from each of the vertices of the triangle. So what that means is if you come up to the vertex of the triangle, remember the vertex? It's kind of like the corners of the triangle. We have vertex A, B, and C. So if we come from the vertex down to the center, the circumcenter, anything I'm putting in green here, if it has equal distance, that means that they are also congruent. Now let's take a look at the incenter. Incenters are created by angled bisectors. So if you look here at your vertices, notice those arc marks. That tells us that these angles are congruent. And what's happening here, these lines are bisecting. They're cutting this angle A into 2 equal parts, 2 equal angles. And they're intersecting at that point of concurrency that we call the incenter. Now, important facts. The incenter is equidistant, and again, that means equal distance from each of the sides of the triangle. So that means if it's equidistant from the sides, all of these segments are going to be congruent. Now, what it also is not on this sheet, we're going to add, we can use this sheet as a nice reference sheet for your test. These sides here will be congruent. AX will also be congruent to AZ. And ZC is going to be congruent to CY. And let's take a look at the centroid. Centroid is created by medians, and now medians are created by connecting the vertex to a midpoint. So again, that midpoint, it's the middle. You're breaking up the segment into 2 equal parts, which means they are congruent. So Z is a midpoint. So if I go from the opposite angle down to that midpoint, I've formed a median. And again, AY is a midpoint. And I know it's a midpoint because these two segments are congruent. That means Y is dividing them into two equal parts. And now I can also go from C to X. Now we have a special relationship here too. If we look at part 2 whole, so AY being the whole segment, that means AM would be 2/3 the entire distance, which means MY would be 1/3 the total distance. If I compare part to part, AM is going to be 2 times the size of MY. And line segment MY would of course then be half the size of AM. And now let's review the orthocenter. Orthocenters are created by altitudes. And if you think about altitude as height, so an altitude is created by a vertex connected to the opposite side so that it is perpendicular to that side. So we're going from the vertex down to the opposite side, and it has to form perpendicular lines. And again, you see that box, that means we have a 90-degree angle. Line BZ is perpendicular to line segment AC. And likewise, we can go A to Y. Here's another altitude. And let's go C to X. Those are altitudes. Now notice we have not necessarily created any congruent parts. We are just going to recognize we have an orthocenter if we have a line coming from a vertex to the opposite side, and it is creating a right angle, which means my line segments are perpendicular. Let's take a look at a few examples on the back. We're going to classify each center as circumcenter, incenter, centroid, or orthocenter. So now here, if you compare that to what we did on our reference sheet on the other side, I can see that this line segment here, this point has to be a midpoint. I've got a midpoint and another midpoint. And if I look at these lines, they are all coming down from the vertex. Now I kind of have two different options here. This could be a circumcenter or a centroid. But remember, with a circumcenter, they're formed by perpendicular bisectors, so you would be seeing some perpendicular lines. We don't have any perpendicular lines here, so this is a centroid. Looking at number 8, notice we have angle bisectors. So we're coming from our point of concurrency in the middle, and this line is bisecting this angle. This is the incenter. My point of concurrency is the incenter. And now number 9. We have a line coming from the vertex down to the opposite side, and it's forming that right angle. So these lines are perpendicular. Notice there's nothing else here saying anything is congruent. These are altitudes. So this is orthocenter. Looking at number 10, obviously we have something coming here that is dividing the legs into two congruent parts. And notice here, I've got that right angle symbol. These two lines are perpendicular, and if it's breaking my leg into two equal parts, that means it's bisecting it. So we have perpendicular bisectors here. This is circumcenter. Number 11, again, notice we have midpoints, and we have lines coming from the vertex to the midpoint. This is the centroid. Number 12, notice your lines here that go from the point of concurrency to the sides. These are all congruent. This is the incenter. And now on number 13, notice we've got our point of concurrency here. We have lines going from the vertex to the point of concurrency, and all of these lines are congruent. That means your point of concurrency is the circumcenter. And now number 14. We have a line coming down from the vertex to the opposite side. It's forming a right angle. So these lines are perpendicular. I don't see anything telling me anything is congruent. These are your altitudes. This is measuring the height of each triangle. So therefore we have an orthocenter.